Hey guys, welcome back to day 2 of Parabolas and Quadratic Equations. We are again going to be on page 161 of your Springboard book, and you'll definitely want a pen or a pencil. Today we're going to be focusing on writing the general equation of a parabola in x equals, though, using key features. So this is going to be when the parabola is open left or right. Okay. So again, yesterday we focused on a vertical axis of symmetry. Today we're going to focus on horizontal, which means your parabolas will look like this, which is kind of crazy because we haven't seen many of these. But really all that happens is it changes it from a y equals to an x equals. And it just switches kind of where your x and y are and your h and k. So it just kind of flip-flops everything. All right, so let's go ahead and take a look at this. We're going to be focusing on A and D. And again, we're going to draw a picture for each. So let's go ahead. All right, so now if you can see, we are focusing on this equation, okay? So first of all, we're still going to draw a picture. We have an axis of symmetry at y equals 0. So that would go through the y-axis at 0. So this alone should show us that it's going to be an x equals equation because the axis of symmetry is horizontal, okay? Then it also tells us that we have a vertex at 0, 0. So that's right here. Let's label that. And then we have the directrix at x equals 1/2. So I'm going to purposely make this like 1 way over here. 1 and -1, let's say, okay? So our directrix is right here. Oh, no, it's at 1/2, sorry. So it's right there. Okay, so remember our rule that your parabola always opens towards the focus and away from the directrix. So we now know that our parabola is going to open this way. And again, we're just doing a little sketch, doesn't have to be perfect. Okay, so now we're going to plug in and we're going to write it as an x equals. Okay. And we're going to do 1 over 4p, but let's figure out what our p value is. And remember from the video yesterday that that is just either your distance from the vertex to the focus or your vertex to the directrix like we have here, okay? So this distance is from 0, 0 to 1/2, so your p is 1/2. Okay, so we're going to plug that in, and I know it's a little bit weird here, but we're going to plug that in. Okay, then be careful here because since we already used the x, y is what's going to be here. And now we also have to flip our h and our k. So remember that your vertex 0, 0, which doesn't really matter for this one, but we would have to flip hk. So we would actually plug in 0 here and 0 here. But in this case, doesn't really matter. So let's go ahead and simplify that. So 1 over 4 times 1/2. Okay. So that's going to be 1 over 2, because half of 4 is 2. Now, be careful here. Just like yesterday when we had opens up is positive, opens downward is negative, if it opens to the left, it is also going to be negative. Okay, so maybe you want to jot yourself that little note. That left is negative, right is positive. Just like we had yesterday, down is negative and up is positive. Okay, so that's huge, important information there. Okay, so far we have -1/2, and then if we wanted to, we really don't need to include these -0 plus 0, so we could just write this if we wanted to as -1/2 y squared, and this could be your final answer. Okay, So x equals negative 1/2 y squared. Or you could leave the minus 0 and the plus 0 there if you'd like to. All right. Cool. Let's try one more. Let's go ahead and try part D. And in this one, it gives us a focus and a directrix. So our focus is at negative 4, 0. And our directrix is at x equals 4. All right, so negative 4, 0 is our focus. Directrix is at x equals 4. All right. So now again, just like yesterday, in this one we don't have the vertex, so we need to find that. And remember, that's just equidistant. So you kind of want to figure out how far apart these are, which they go from negative 4 to 4. So they are 8 units apart. So we're going to just move 4 in from each side, and that is where your vertex is going to be, kind of like a midpoint, okay? So now again, we have a vertex of 0, 0. We know what the parabola is going to look like because remember it has to open towards the focus and away from the directrix. So we have a quick sketch there. And it opens to the left again. So remember, left is negative. So we're going to write this as x equals negative 1 over 4p, which in this case our p could either be the distance from the focus to the vertex or from the vertex to the directrix, either way, both 4, so p is 4. And then again, be careful because now we want to write this as y minus, and again, your vertex is 0, 0, so we would put plus 0, plus 0. And so now let's go ahead and simplify, and we would write it as x equals negative 1 over 16, and then we could just write y squared. Okay, and that's your final answer. All right, so these two examples were somewhat similar in the fact that both of their vertex was at 0, 0. So we'll look at some more in class tomorrow where the vertex is in a different spot and we have to change the h and the k. We'll also kind of put them both together tomorrow so that they won't be separated, vertical axis of symmetry versus horizontal, and you'll have to figure that out. And so we'll just do some practice with all of these tomorrow, okay? So if you have any questions, bring them to our Zoom tomorrow. But other than that, have a good one. Bye-bye.